Welcome to Monday. We will be discussing Newton's laws this week to kind of just go forward from last week. I'm not sure what we'll be doing next week. It sort of depends on the interest survey that you guys filled out last Monday. So we'll see. But this week we're working on Newton's laws. And the first concept is force. So you guys should have notes on the bottom. It should say page 20. And on the top it probably says Monday, June 22nd. And we will be kind of just going through that note sheet right now. So force, it's just the push or pull one object exerts on another. So feel free to go ahead and fill that out on your sheet. And it's measured in newtons. So a newton is the same thing as 1 kilogram times meters, kilogram meters over second squared. Saying newtons is a lot easier, so just think of it as 1 newton. I would write that on there on your note sheet as well, that it's measured in newtons. Forces can cause a change in an object's motion, and more than one force can act on an object at one time. And a net force, which is the next thing on your note sheet, is the combining of forces when 2 or more forces act on an object. So we'll have a little example here. So if these books have a force of 2 newtons pushing them to the right and 5 newtons pushing them to the left, we have something called the net force, which is 3 newtons to the left. So it's the 3 newtons, which is 5 minus 2, right? And then which direction will the books move? So now forces can be balanced or unbalanced. Balanced forces just have an equals. They are equal in size and opposite in direction. They don't cause a change in motion because the net force on the object is 0. 4 newtons pushing these books to the right, 4 newtons pushing them to the left, the net force is 0, right? So they're just going to stay in one place. So an unbalanced force would be forces that are not equal in size and they are opposite in direction. Here's an example. Net force causes the object to move in the direction of the force, right? So 2 newtons pushing the books to the right and another 7 newtons pushing those books to the right with only 3 newtons trying to push them to the left, which means we have a net force of 6 newtons to the right. So which way would those books slide across the table, for example? They'd be sliding to our right as we're looking at it. Which brings us to Newton's first law of motion. Sir Isaac Newton came up with 3 laws in 1687 that describe how forces affect an object's motion. Hopefully you guys already watched the video, so you know who Sir Isaac Newton is. And this is Newton's first law. It's an object will move at a constant velocity until a net force acts on it. An object in motion will stay in motion unless a force acts on it. Feel free to write whichever way makes the most sense to you. I kind of like an object in motion will stay in motion unless a force acts on it. And an object at rest will stay at rest until a force acts on it. So it's 2 pieces, right? So here is our example. It's called the law of inertia. So I would put that on there somewhere. Law of inertia, put that on your note sheet because that's the official name of it. And what is inertia? We do need to define that. It's the tendency of an object to resist a change in motion. So the more a mass an object has, the more inertia it has. So when you slam on your brakes, your body still flies forward because it wants to stay in motion like it was before you braked. When you're in a car, if your car is going 55 miles per hour, you are actually going 55 miles per hour. So if you slam on your brakes, your body still wants to move 55 miles per hour forward. So that is why we wear a seatbelt, so that our bodies don't just keep going forward when the car stops. That can cause all sorts of injuries. Okay, so now we're going to do a little practice. The practice is force in Newton's first law. Looks like we have 10 questions, and that will be a separate video.